we are talking about oxyacids of halogens. About that already I was discussing, but let us revise in short. Acid strength of these oxyacids having same oxidation number means what? If I consider chlorine as a one halogen, other bromine, third one iodine, means those oxyacids which have the same oxidation state for the halogen. If I consider chlorine in +1 oxidation state, bromine in +1 oxidation state, iodine in +1 oxidation state, then respective oxyacid will be the formula HOCl, HOBr, HOI, means OH will be attached to those halogens. Here chlorine, bromine and iodine all are in same oxidation state. Similar way, what one can consider? A chlorine in +3 oxidation state, bromine in +3 oxidation state, iodine in +3 oxidation state. Then respective oxyacids will be with the formula HO2Cl. Students, are you understanding what I am saying?
Yes, sir.
HO2Br, HO2I. Here what is happening? All halogens are with same oxidation state. In such cases, how acid strength will vary? Will decrease with increase in size. Means among those who will be the strongest acid, HOCl will be the strongest acid. HOBr will be the strongest acid compared to HOI. Here HO2Cl will be the strongest compared to HO2Br. Which will be the strongest compared to HO2I. Why it is so? Because electronegativity decreases as we go from chlorine to iodine. Now question you will be with, what is the role of electronegativity? Just pay the attention here, the bonding, the chlorine and OH bond. Compared to iodine, chlorine is more electronegative. Because of that, what will happen? It will attract, which is bond is there, no? That bond pair towards itself, more towards itself, electrons will be attracted. Because of that, it will be easy to break the bond and hydrogen can come out in the form of H plus, causing acidic behavior. Therefore, we say HOCl is strong acid compared to HOBr, which is strong compared to HOI. Is it clear or shall I explain again?
Clear, sir.
Waiting for at least one answer.
Clear, sir.
Clear, sir.
Okay. Yes, here explanation is given. This is a reason that withdraw electrons from oxygen atom towards itself, because that halogen will withdraw electron from oxygen towards itself. So oxygen will withdraw electron from OH bond so that H plus can easily remove. And that withdrawal of electron, that tendency decreases from chlorine to iodine. Now see the next statement here, completion of the answer. As a result of this tendency to pull electrons from hydrogen, that decreases and release of hydrogen ion becomes difficult. So in case of this HOI, in case of HO2I3, or suppose if I consider those halogens in the +5 oxidation state, then HO3I will be there. If I consider those in the +7 oxidation state, HO4I. So those will be with less acidic behavior. So acid strain is this one. So in true sense, it is the conclusion. And above things are there. Those are just the explanation for the acid strengths. So acid strength is one point included in your syllabus. Next point is the oxidizing power, oxidizing ability, as well as thermal stability. That oxidizing ability means they oxidize the other component, other reactant, so they themselves undergo the reduction. So oxidation number, if you observe here what they said, oxidation number of halogen, here HOCl, oxidation number of chlorine, here in HClO2, oxidation number of chlorine in HClO3, oxidation number of chlorine in HClO4. Different oxidation numbers are there. What is the statement? If oxidation number increases, oxidation power decreases. I want your help, student. What is the oxidation number of chlorine here in HClO4? Waiting for answer.
8.
Plus
Loudly,
7.
please. Yes. Exactly. The oxidation state of the chlorine is +7. In case of HClO3, oxidation state of chlorine,
+5. +5.
exactly. In case of HClO2, oxidation state of chlorine,
+3.
Three.
yes, brilliant answer. In case of HClO, oxidation state of chlorine,
+1.
yes.
+1.
So +1 to +7, there is an increase in oxidation number. What we find? Oxidation power decreases. So who has more oxidation power? HClO has a more oxidation power. Then HClO, then HClO3, and then HClO4. It is our first statement. What is the reason for that? The reason is, see, halogen oxygen bond becomes more covalent. Where it becomes more covalent? In case of that more oxygen possessing oxyacids, it becomes more covalent. As a result of that, what happens? See, because along with the oxidizing power, we are discussing thermal stability. As a result of that, thermal stability increases. Of whom thermal stability increases? It is of HClO4. Where oxidation number is larger, its thermal stability will be the larger. So because of that, what they are saying? Thus, hypohalites means these are the salts of hypochlorous acid are stronger oxidizing agents than whom? Perhalates. Perhalates means what? A salts of perchloric acid. Okay, one thing you should know here, how we understand these haloacids or chloroacids. The first acid where oxidation number is +1, that is hypochlorous acid, which is that HClO. Second acid where oxidation number is +3, its name is chlorous acid. It is represented here, HClO2. Next acid where oxidation state of chlorine is +5 is chloric acid. It is represented here. Last is perchloric acid. It is represented here. So these are the names of acids. If its salts are to label, then hypochlorite. Here chloride. Okay, chlorides. Here chlorite. Here chloride, chlorite. And here perchlorate or perchloride. Here only depends chloride and what the chlorite. So sulfide and sulfite. Likewise, it's just only simple differences. So here what you will find hypohalite means salt obtained from hypochlorous acid. Chlorate. Salt obtained from this perchloric acid. These perhalates are weak oxidizing agent compared to hypohalites, or their stability is what here more. Perhalate stability is more. Our point of interest is oxidizing agents. Who is strong oxidizing agent? Hypochlorous acid or its salt hypohalites, hypochlorites are strong oxidizing agent. Last time during discussion, I remember I told you one practical example. Yes, one salt of hypochlorite. Yes, what is the practical example? One powder that I said. Which powder?
Bleaching powder.
Yes, that bleaching powder remains with these hypochlorites. Because of its oxidizing power, we use it for purification purpose, water purification purpose. Okay, now see the explanation. With increase in oxidation number of halogen, thermal stability of both acids and salt increases. Thus, stability of oxyacids are in the order HClO, HClO2, HClO3, HClO4. Upper point was regarding oxidizing strain, oxidizing ability, and this lower point is regarding thermal stability. They said this thermal stability point, that thermal stability is increasing. It is because more covalent character. It is because, just example, I take HClO4 and HClO. If I have to represent HClO, then chlorine and OH. Only one bond. Exact structure we are studying later on. If I have to represent structure of HClO4, then I have to represent chlorine, one oxygen, second oxygen, third oxygen, and one OH bond. It's HClO4. If you see, compared to this structure, here number of covalent bonds are more. and because of that it gets more stability, thermal strength, thermal stability, and that is our point. The stability of oxyacids are in the order perchloric acid is strongly stable compared to hypochlorous acid. Students, is that second point of stability clear?
Yes, sir.
Yes, sir.
Okay. Explanation is as the number of oxygen atoms increase in ion, there is greater dispersal of negative charge. Therefore, greater is the stability of ion form. Means whatever that negative charge is there. So suppose if I now pay proper attention here, this OH bond is there. I remove this hydrogen. If I remove hydrogen, what will be there? Which charge will be there on the oxygen after removal of hydrogen? I repeat, here hydrogen was there. If I remove that hydrogen, then oxygen will be with which charge? Yes, here on this oxygen, which charge will be there? See, hydrogen goes in the form of what? H plus form. Because oxygen is more electronegative, so it will fetch the bonded pair of electron towards itself. So hydrogen will go in the form H plus. If H plus goes, then what will be the charge on oxygen?
Minus.
Yes, here will be the minus one charge on the oxygen. And that charge is a load. Actually, is a negative charge a load. It causes imbalance. But in order to give balance, in order to distribute that charge, other oxygens will come. One time, what this oxygen will say, I will bear that charge. So this double bond will go, and that double bond will come on this oxygen, and that negative charge, whichever is there on this oxygen, that will go and will come on other oxygen. So likewise, this charge can come maybe here, maybe here, maybe here, maybe here. Many opportunities are there for that negative charge for dispersal. That's a resonance effect. And because of that, that whatever that ion is there, what's the name of that ion? ClO4 minus perchlorate ion. That perchlorate ion is stable compared to whom? ClO minus. Here only one oxygen. There are no other friend is there for the oxygen to distribute the charge, to take the charge. So synergic moment or distribution charge is more in case of the perchloric acid ion, and because of that it is thermally stable. So therefore HClO4 is thermally more stable. It is relatively less stable. It is further less stable and is further less stable HClO. So how the thermal stability and acid strength varies. See how the acid strength is there, acid strength variation, exactly opposite of that is the thermal stability. I am giving the explanation of dispersal of that negative charge. Here it is said, no, greater dispersal of negative charge, and therefore it is more stable. Is it clear?
Yes, sir.
Yes. Now see the last. Acidity of oxoacids of different halogen which have same oxidation number decreases from chlorine to iodine. Which strength? See here. Acidity of the different halogens with the same oxidation number decreases from chlorine to iodine. Means previously whatever the example that I had given, similarly I represent here. Now the oxidation state is same. HOCl, HOBr, HOI. Yes. Now answer for my question. Everywhere halogen is with plus one oxidation state. As per this statement, answer for my question, who will be the strong acid, HOCl or HOI? Already answered that. Already I had given answer, and that answer is in the statement. Read that statement and apply that statement.
HOCl,
What HOCl, strong or weak?
strong.
Yes, HOCl will be strong compared to HOBr, HOBr will be strong compared to HOI. What is the reason behind that? Reason is the electronegativity. Chlorine is more electronegative, so that bonded pair will come to the chlorine. Because of that, oxygen will be more greedy and it will move this hydrogen fastly compared to from HOI. So they said that oxoacid with different halogens which have same oxygen number decreases from chlorine to iodine, and this is due to decrease in electronegativity with increase in size, about which we had a discussion. Yes. Any question about this?
No, no, sir.
No,
Yes.
sir.
Now I come to the actual point of the structures for these oxyacids of halogens. Okay, out of that, one I consider as a chlorine. Now I need your help. The oxyacid of chlorine with +1 oxidation state of chlorine. What's the name of that formula?
Hypochlorous.
Yes, hypochlorous formula.
HClO.
Okay, HOCl or HClO. Here basic you should be with. We are discussing this on the basis of VSEPR theory. If you consider any halogen, then halogen will be with how many electrons in outermost orbitals? Any halogen if you consider, then its electronic configuration remains a noble gas followed by Ns2Np5. So 7 electrons are there in outermost orbitals. If I have to talk about the p orbital, then here only 5 electrons will be there. It is in case of the chlorine. If you think about the oxygen in general point of view, oxygen atomic number is 8. After completing the helium electronic configuration, 2s2 to p4. So here in p orbital, 4 electrons are there. First electron, second electron, third electron, fourth electron. So what can you find? Here 2 electrons are there, those are unpaired electrons, and because of that oxygen will eager to take 1 electron, eager to take second electron to pair here. So oxygen will generally show the -2 oxidation state, and among this if I have to compare oxygen and the chlorine, answer for my question, among these two, who is more electronegative, oxygen or chlorine? Comparatively, oxygen is more electronegative, and therefore oxygen will do bossing on the chlorine and will take the electron from the chlorine. Means it will compel chlorine to be in the +1 oxidation state, and it will itself remain in the -2 oxidation state. Out of that 2 electron, 1 electron will come from hydrogen and 1 electron from what? The chlorine. So if in general sense you have to understand HOCl bonding, that HOCl bonding will be in this way. So how many lone pairs are there? That we have to find out. Now listen very carefully. The basis for the VSEPR theory that I am telling to you, there a first point will be outer electrons on central atom. That's a chlorine. How many outer electrons are there on the chlorine? 7. Outermost orbitals, outermost shell that I discussed. 7 electrons total are there on what? The chlorine. Yes, students, are you following what I'm saying?
Yes, sir.
Yes.
Yes. A second point, number of bonds that chlorine forms. Here chlorine forms only one bond. That's a 1. Third point, number of lone pairs. How to find them? A. This is a number A. Minus B. This is a B number. Divide by 2. So what will you get answer? Which is equal to 7 electrons are there on the chlorine. Out of that 1 electron to form this one bond. Divided by 2. Yes, what's the answer?
3.
Yes, there will be 3 lone pairs. 3 lone pairs. And how many bond pairs will be there? Number of bond pairs. Number of bond pairs is number of bonds. How many bonds are there?
1.
Yes,
1.
only one. Okay. Now, last point is a very important one. Total. Total of what? Lone pair plus bond pair is equal to that 3 plus 1 you will do. 3 plus 1 is equal to 4. If 4 species are there, means what are these? This 4 means what? These are stereoactive species, or you can say 4 is a steric number, and that steric number decides the geometry. I want your help. If 4 is a steric number, then what can be the geometry? 4 species are
Tetrahedral.
there. Yes, absolutely. Tetrahedral. So all these 4 species will arrange in tetrahedral manner. So if I have to represent the structure on the basis of VSEPR theory, then I need to consider chlorine at the center, and that chlorine is going to form one bond with oxygen, and hydrogen is bonded to the oxygen. It is only one bond pair, but total 4 species are there. So how can I represent those 4 species? One species here, there will be lone pair. Such how many lone pairs are there? Help me.
3.
Yes, such 3 lone pairs are there, and I am representing those 3 lone pairs here. Means geometry, if you see, geometry is tetrahedral, but shape of the molecule, if you see, it is linear. It is the understanding of structure of hypochlorous acid. I repeat point wise. If you want to note down the points, Note down the points, and with that you have to give the explanation for other oxyacids of the halogen. If you want, I'll give one more explanation also. See the points which we have covered. We know that chlorine has a 7 electrons in its outermost orbitals, total 7, and from the bare formula we can guess the number of bonds 1. From that we can find out number of lone pairs, number of electrons minus number of bonds divided by 2. Those many lone pairs will be there. Number of bond pairs is equal to number of bonds. So it is 1. Total number of stereoactive species means lone pairs plus bond pair is equal to 4. The number 4 signifies that geometry will be tetrahedral. Geometry I am saying. Stereo arrangement will be tetrahedral because steric number is 4. So structure we can represent as chlorine at the center. Here 3 lone pairs around and 1 bond pair. So geometry is tetrahedral and shape is linear. Is that explanation clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes. Now
Yes.
let me know which example shall I give? Shall I explain? See, total 3 acids we are discussing. One hypochlorous acid, other chlorous acid, chloric acid. Actually, 4 we are discussing, and perchloric acid. Out of this first I had discussed. Now I want to discuss one more, and remaining I want to give you as a homework. If necessary, one more addition I can discuss. Now I want to know answer from you. Which shall I discuss? This chlorous acid, chloric acid, or perchloric acid?
Perchloric acid.
Yes, perchloric acid I discuss now. Formula is H. Yes, help me. What is the formula?
HOClO3.
No.
O4.
Yes, HO4Cl or HClO4 is a perchloric acid. As usual, our first point, central atom. Which is that? Which central atom is there?
Chlorine.
Which halogen? Yes, chlorine. Because of that, we can get outermost electron. Outermost electrons on chlorine. Yes, help me. What's the answer?
7.
7. Now point B. Number of bonds that chlorine undergoes. Yes. Number of bonds around chlorine. Yes. Can
4.
I answer? How many?
4.
4. Okay. You are saying 4. Apply logic and then tell me. I had given already the basic. The chlorine is there, is showing the positive oxidation state. Oxygen is there. Atomic number is 8. Oxygen needs how many electrons?
4.
Oxygen wants how many electrons? Maybe from chlorine or maybe from hydrogen.
2.
Yes, oxygen is in need of 2 electrons. Then only oxygen will do the friendship. It may possible 1 electron from chlorine and 1 electron from hydrogen. And it happens there. If I consider chlorine here, 1 oxygen and 1 hydrogen. 1 electron from hydrogen that oxygen is getting, 1 electron from chlorine it is getting. But it is not always. Only 1 hydrogen we are with. Remaining hydrogens are not there. So now here I consider first oxygen. Such how many oxygens are there? 4 oxygens are there. Here is second oxygen. Here is a third oxygen. Here is a fourth oxygen. Yes.
4
Now
bonds.
I want to know from you. How many bonds will be here between this chlorine and oxygen? Here how many bonds are there in between chlorine and oxygen?
4.
No, between 1 chlorine and 1 oxygen, how many bonds? I told you oxygen wants 2 electron. Even if you take, yes, even if you take oxygen molecule, O double bond O is a structure of oxygen molecule. So oxygen will not compensate anything. Oxygen wants double bond. This oxygen also wants double bond. This oxygen also wants double bond. Now answer for my question. How many bonds are there around chlorine?
8.
8.
No. Around chlorine I am saying. By chlorine I am saying. Okay, I want your help.
7.
I want your help. Tell me, between this oxygen and chlorine, how many bonds are there?
2.
Yes, only one
1.
bond is there. Only one bond is there. And because of that only one bond, here see, this is only one bond. This one bond, here 2 bonds, 2 bonds, 2 bonds. That summation only you have to do. Tell me, how many bonds are there?
7.
Yes, 7 is a correct answer. Yes, students, are you getting the point?
Yes, sir.
Now if you see the next, number of lone pairs, which is equal to, if I consider it as a number A, it as a number B, the formula is A minus B divided by 2. So what I should substitute? 7 minus 7 divided by 2. Yes, help me. What's the answer?
0.
Yes,
0.
there is a no lone pair at all. Now, at least I want answer from you now. Number of bond pairs is equal to how many bond pairs are there around chlorine? Waiting for your reply.
7.
4.
Number of bonds. Number of bonds means number of bond pairs. How many bonds are there around chlorine?
7.
Yes, already you have answered. The same answer I want here. Number of bonds means number of bond pairs. 7. Is it clear? Students, are you following?
No, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. See, bond pair means number of bonds. That number of bonds already we have answered. 7 are there. So now we want steric number. Steric number is equal to this number of lone pairs and number of bond pairs. So write that lone pair plus bond pair, which is equal to 0 plus 7. Yes. What's the answer? What's the
7.
answer? Yeah, it should be 7 as per our this. But here, in case of the bond pairs, just I represent, just wait. If you see the structure, it is a one steric arrangement. It's a double bond. Here is a double bond. Here is a double bond. Here is a single bond. So our usual logic is not applicable here. Number of bonds, whatever you said, are 7. Absolutely right. Somebody said here. Number of bonds are what? 7. But number of bond pairs. Here double bond is a one kind of the stereoactive species. So here what will be there? In spite of 7, which number will be there from this diagram? How many total stereoactive ways are there by which it can arrange? Double bond is a one stereoactive species. Number of double bonds and number of single bonds. Okay, or else what you can do? You can understand this as number of double and single bond or bond pairs. How many are there? Double, how many are there? How many double bond pairs are there? How many double bonds are there? 3. How many single are there? 1. So here number of the double and single bond stereoactive species will be only 4. Somebody had already wisely answered the number 4. Yes, students, are you getting this point what I'm saying? No, if no, then say no.
Yes. Yes, sir.
Okay, so now correct me. Now stereoactive species or steric number will be 0 plus, what should be there? 0 plus 4 is equal to 4. If steric number is 4, then geometry will be, yes, which geometry will be there?
Tetrahedral.
Yes, tetrahedral. It is understanding of the application of VSEPR theory to perchloric acid. So how can I represent the structure? Chlorine will be at center. There will be one OH bond. There are 3 double bonds. So how can I represent those 3 double bonds? I can say represent here one double bond. Here is a second double bond and here third double bond. And those double bonds are with whom? Oxygen, oxygen, oxygen. It is our HClO4 or HO4Cl or perchloric acid. Structure is tetrahedral. Geometry is tetrahedral. Shape also is tetrahedral. Is it clear?
Yes. Yes, sir.
Okay.
Yes, sir.
Similarly, can you answer the structure of HO2Cl and HO3Cl? Is it possible?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Then that will be the homework for you. You have to complete the structures for all. 2 structures I have explained. So which points we have covered today? The first point about the acid strength of haloacids or acid strength of acids of halogen, oxyacids of halogen. Second point we have covered oxidizing power, and third point thermal stability. Afterwards we come to the structure of these all oxyacids of halogen. For that I took only one example, chlorine, hypochlorous acid, chlorous acid, chloric acid and perchloric acid. Their structures on the basis of VSEPR theory pattern I told to you. You have to apply and you have to describe the structures of all 4 oxyacids of chlorine. Chlorine as one example. Are these all points clear?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes. It's a homework for you. Recorded lecture I will upload by night. Next time interhalogens you have to study. After study of interhalogens, our syllabus nearly will complete. Only superconductivity portion is there that you can perform. Superconductivity and non-aqueous solvent. So it is for your work. If questions are there, we can have the discussion. So you will get a sufficient time for the revision. Those points, those topics also we can cover. So in next lecture, may I cover the interhalogen compounds and their structures. Again, it is on the basis of VSEPR theory. Is the planning clear?
Yes, clear, sir.
Yes, sir.
Yes.
Yes. And about the practical, I tell to you on Friday, actually, I wanted to show demo. Roddick sir said that I have to conduct one experiment of analytical chemistry. I thought that flame photometry, because previously when flame photometer newly came, I was working with that. Means I was teaching the student. So I thought that Roddick sir want to say flame photometry, but Roddick sir may want to say the other. But already Chandra Skuperkar and all, he did the arrangement. And I asked Patil sir, so Patil sir said that I can conduct the flame photometry experiment. If needed, Patil sir can conduct that again. Theory also he can explain you if he wants. Or if other experiment come to me, Patil sir will conduct that. That internal adjustment that we will do. So tomorrow may possible I will record it. It's an analytical chemistry pending practical I'm saying. Inorganic chemistry practical is there, about which tomorrow I will give the information. Few experiments are there, those are already recorded. About those recorded experiments, I'll give the information. You can work with them. And those who are not recorded, I will work for the experiments. I will show you the demonstration and you are allowed to ask the question. Is it clear about planning about the practical?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yeah. Okay then. All are not spontaneously replying. It is a very bad situation. Only few students do all the replying. Next time I don't want this. Let me know how many of you reply at this moment. You have to reply by talking, by communication. Reply. Whatever
Yes,
the
sir.
planning for inorganic chemistry syllabus I had given and the practical coverage that I had given, is it clear to you?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Neha, Ankita, Shubhangi.
Yes, sir.
Why you not
Yes,
replied,
sir.
Neha?
Yes, sir.
Shubhangi, now you are replying. Supashi
Sir,
now
net.
replied. Ganesh, Swapnali. Ganesh, can you hear me? Now, see students, those who have delayed now, no? For example, Shubhangi, Neha, they have delayed now. Rupashi also replied now. Ganesh yet not replying. It is not fair. You should remain in the communication. If problems are there, bring it to the notice. Okay, then I stop the recording and I declare here today's session is over.